pictures in the lab?
Yes, video.
Oh.
So tell me about the machine.
This is the HPLC, the High Performance Liquid Chromatography machine.
Oh.
And it's used to determine the concentration of different components that are in liquid. So sometimes they take the supernatant from bacteria or the leftover media that has byproducts from bacteria, and they find out what is in the solution. Here, the concentrations using different peaks, and they analyze them.
Right.
This is the microplate reader. We use it to grow bacteria in a micro plate.
Oh, you do?
Yep. Well, some people do. This is the PCR machine, polymerase chain reaction. Once we are able to extract DNA from bacteria, we amplify the DNA so that we have more of it, or more of a certain part of the DNA. Because genomic DNA can be like about 1 to 2 or 3 million different letters or base pairs or chemicals. But if you just want to amplify like 200 base pairs, you'd use, or 1500 desired a certain target on the genome, you use a PCR machine.
Right.
This is a microcentrifuge.
Oh.
And we use this to spin down samples. So if you have a vial or a tube, you just put the tube, something like this. This is a tube. You just put the tube inside, and then you put that black thing on top, and then you spin it. And what it does is that any bacteria that is inside of the tube gets pelleted to the bottom, and then you can wash off the liquid, and you'll have more concentrated cells.
Right.
This is just a water bath if you need to heat something up in water at a certain temperature.
Of course.
And then these are incubators, so if you need to grow something at a certain temperature, like 37 degrees Celsius, it should be body temperature, then you just use a flask. And if you need to shake it to get more air in there, then that's what you do, use a shaker, and the tubes are slightly open so that the air can go into the flask.
Right.
These are our lab benches. They were clean last week, but this week they're not so clean.
Why is that?
People just don't clean them. They don't clean them. This is the gel dock. So after you use the PCR machine and you have a lot of DNA of a specific target, you know what size that DNA is supposed to be. So you make a gel, and then you put the DNA in the beginning of the gel on the edge, and then the DNA is negatively charged. So you have a negative charge behind the DNA and a positive charge, and then a positive and negative charge attract each other. So the positive charge causes the DNA to travel down the gel, and that way, based on the sizes, they're able to separate. So a smaller size band can go farther than a larger size DNA, and then when the DNA travels, we call that a band because it looks like a band in the gel. We make the gels here, and we have a ladder so that has like different sizes of DNA in it so that we can compare the length of our DNA fragments.
Of course.
So this is also a lab bench here, different lab benches. Yep. This is our old fridge that broke. So we never got it fixed. So now we just put supplies in there that we need. Nina plans on fixing it someday. This is algae that grows inside. Yeah.
Is it?
Yeah, it's algae. We have it at a certain temperature. It's bright to mimic the ocean. It shakes to mimic waves. And it's at the right temperature as the sea, apparently. Yeah.
Alrighty then.
We keep all of our chemicals in here. We have a lot of chemicals. They're in alphabetical order so that you can choose what you want. Then this is the outdated list of all the chemicals. We probably should make a new one. And then if we need to order something, we put it here so that we can order. This is the microscopy room. So if you
Oh, is it?
Yes. If you look in the back, there's a microscope, and we use that to image. I image my droplets, and I make droplets there sometimes. I don't use any of that equipment. That's in the Burns lab. They
Oh.
do microfluidics.
Okay. This is the microscope you use here?
Yes, it's one of them.
And what's this machine?
That's a fluorescence machine. So if we have a sample that is fluorescently tagged, we turn that on and we're able to see different like channels, or we use different excitations in order to see different colors from fluorescence. Hey, this is my dad.
Oh,
I'm giving him
hi.
a tour.
Hi.
Hi, nice to meet you. Yeah.
Hey, what's your name?
Jason.
Hi, Jason.
Yeah. Branch group.
Huh?
Branch group and different
Oh,
group, but
yeah.
we share.
Okay, it's okay. You're in the lab.
Yeah.
Yeah, he's in the Burns lab.
In the Burns lab.
I have one more lab to show you.
Okay. Nice meeting you.
Yeah, me too.
So this is the lab that I work in most of the time. It's called the Biosafety Level 2 lab. It has no windows, but I don't care. So this is a hood. If we have any toxins, we just put them there, and the fumes should be put into the vent so we don't breathe them in. This is our sink for washing whatever we need to washing our hands. These are my pipettes that I use over here. So I have all different sizes, 1,000 microliters, 200 microliters, 220, and 2.5. Some calculators for doing work. And then a lot of my bacteria, they don't really survive in oxygen, or they're sensitive to oxygen, or they react differently when they're in the presence of oxygen, but they can grow without oxygen. So this is an anaerobic chamber where there is no oxygen inside. So we have to be very careful when we transfer things inside and take them out to make sure that the oxygen stays on the outside.
So what is it, nitrogen?
So this is 80, it's nitrogen, carbon dioxide, and hydrogen. It's 5% hydrogen. Yeah, 5% hydrogen, 5% carbon dioxide, and 90% nitrogen. And then this right here is a purge system that I made. So if I'm making media or making a solution, then it'll be exposed to air and it'll have lots of air inside of it. But here we're able to turn on the gas tank, and then it flows nitrogen out, and then we'll open this up and we'll put some flames underneath, and it will start to boil. And as it boils, I'll put this nitrogen purging needle inside, and then it will blow nitrogen inside. And the reason why this is blue is because we poured Resazurin inside, which is an oxygen indicator. So if it's blue, that means it's oxygen. If it's red, if it's pink, that means there is some oxygen inside. But if it's clear, that means that there is no oxygen. So this is a qualitative way to tell if there's oxygen inside or not. But yeah, I made this myself, so that was cool. Nina was proud for a second. Okay, and this is a stir plate. So if you have a solution, you just put it there, and then you stir it, and it'll stir for you. You put a magnetic stir bar inside. And that's everything.
Okay, thank you, Corine.
You're welcome.